Yeah, so this is a talk on using BladeRunnerJS, which is a solution that we've just open sourced to build front-end JavaScript apps at scale. Although this is a sponsored talk, you might have noticed, we do believe that some of the ideas that we've come up with and the way that we write these large-scale JavaScript applications will be applicable with other tooling and with other libraries. So my name's Phil Legater. I work for a company called Caplin Systems based in London. And the tool that we've open sourced is BladeRunnerJS. Version 0.4 just last week. So at Caplin Systems, we enable our customers to build web trading applications, so web trading platforms. But as part of that, building the full web trading stack, they need to build an HTML5 front end. So this is around 100,000 plus lines of code, loads and loads of assets, contributed to by many, many developers. Over the past couple of years, we actually started doing this sort of stuff in 2001 when I jumped Caplin for the first time in 2001, and we were doing this sort of thing then in a much hackier way. Now we're doing it in a much less hackier way, but only because of the tooling. So in the past few years, we were in a world of pain. We had loads of problems in terms of building these very complex front-end applications. So we needed tooling to support that development workflow. So that's exactly what BladeRunnerJS is. So just to give you some framing, it's a toolkit, and it's written in Java. It's modular and extensible. And what that means is that as we were in this world of pain, we kind of reverse engineered the problems that we had, and we identified things that were potentially subject to change. So, for instance, the way we wrote JavaScript was horrible, long namespace JavaScript, and we decided we wanted to write Node.js-style JavaScript code that ran in the browser. But we know that ES6 is coming along. We also know that in enterprise land, TypeScript is getting a bit of traction, so that might be an option for us. So that's an example of the sort of things that we're making plug-inable. We want to be able to support these other types of languages, and that's what we've done with the whole toolkit. We tried to identify things that can change and make those plugins. Now, this is quite a grand claim. We're obviously not doing everything that these things are doing, but we're doing bits of what these things are doing. So if you needed an idea of what it is that BladeRunnerJS is, it's kind of yeoman, grunt, broccoli, browserify. It's a thin level of application architecture and some micro libraries. We've come up with a couple of new concepts which actually fit reasonably well with the idea of web components, the idea of blades, a vertical slicer functionality, and workbenches. And you'll see more about what those are shortly. And it's important to stress it's not a replacement for Angular, Ember, and web components. It's not just this front-end runtime. So hopefully that's clear. I know people kind of go BladeRunnerJS. It sounds like a framework. It's not. So we actually use Knockout.js at the moment, but we've done some hacks around AngularJS in terms of how we can, we've looked at how we can integrate that and add support for it, but ultimately it's just adding libraries to our runtime, and that's relatively easy. And the whole focus with all of this is that we want to build trading applications for our customers, and we want to do that relatively quickly. We want our developers to have a productive experience. So the focus is on building features. The first line of code we write should either be a test or should be feature code. So now the meat of the talk is covering what is a large-scale JavaScript application. Let's define what that is. I want to identify some of those pain points, some of the signs of scaling that maybe if you guys are building complex JavaScript applications, that might resonate with you. And then talk about the solutions, so some demos. Now, because it's only a 30-minute talk, the demos are relatively rushed, but we'll be around. We're going to head to the Google Community Lounge after this. We've got a birds of a feather table booked tomorrow, table number 7. So if you feel this is a bit rushed, or if you generally just want some more information, then please just grab us. So let's define a JavaScript, what a large-scale JavaScript app is. So Adi Osmani's already had a number of shouts today. Some people didn't appreciate it, the guy with the beard. So he talks about basically a large-scale application is something that requires a lot of maintenance. That makes sense. You've got potentially a large code base that's been around for a long time, that will be around for a long time. It's got complex functionality. It's going to require maintenance. And also the browser itself is doing the majority of the work. And this is a shift we're seeing the majority of the functionality being shifted to the browser, whether that's data manipulation or display. There's going to be a large code base. A lot of this is common sense. The more functionality you have, the more code there's going to be to support that functionality. It doesn't matter how good a developer you are and how many times you refactor and look at reducing code duplication, you're going to have more code. For instance, our SDK is around 131,000 lines of code, 95,000 lines of test code. And this SDK is the thing that we build our trading applications on top of, and customers build their trading applications on top of. And a typical app will be 50,000 lines of code that they build, 21,000 lines of test code. So, loads of assets, loads of JavaScript. In addition to that, there's HTML templates, there's CSS, images, ITN for language files, and config. Then there's complexity. So who uses Gmail? Everybody? Everybody, okay. Is anybody going to argue with me that it's a complex front-end application? No, okay. So we all appreciate it's a single-page application. It offers lots of functionality, all running in the browser. This is an older version of our Caplin Trader-based application, one of our demos. You'll see we've got a whole bunch of layout management. We can drag things around. We can move components. We've got these trade tiles up here. We can execute trades. We can launch little tickets. I'll just wait until we move on to a tab. So these are actually quite complex trade workflows in the background, communicating with backends, with streaming servers, potentially other systems interacting with it, charting, chat, real-time news, grids, and so on. So you can see, again, that's a complex application. It's a large single-page app, and so is Gmail. There's complex functionality, but also complex interaction, both in terms of the user. The user has to do some relatively complex interactions with that application. Although, as Elia was saying this morning, we need to really concentrate on the user experience of these sort of things to make sure we're getting it right and it's easy to achieve things. But also interactions in terms of the technology. So the front-end components, how they communicate with each other, and also front-end and back-end components. There's lots of interaction going on there. And these are the sort of applications that you leave open all day. I have Gmail running in tab all the time. Only if I ever need to restart Chrome or something does it ever stop. And that's the same with these trading applications. The trader starts the day or starts the week, opens up the trading application, and it's running all the time. We've probably got a scale where we've got websites and we've got desktop replacement applications. We're focusing towards that desktop replacement application end. Contributors. Now, this is often overlooked. I think when we're building these big apps, that you've got a massive code base that cannot be maintained by one person unless you've got an absolute genius working for you that wants to work all hours that God sends. So there will be multiple people that contribute to that application, multiple teams. And also that code base, as I mentioned, will be around for a long time. So we have loads of different types of contributors. It's a front-end application. You're going to have loads of front-end developers or front-end developers contributing to it. You might have back-end developers at least saying how they expose a service and how you should interact with it. So there's in some way contribution to that application. There's designers who might be adding assets or editing CSS and HTML or adding JavaScript behaviors, QA, technical authors, and so on. And these people might be on the same team, or they might be on multiple teams within the same company, or even across multiple organizations. So, for instance, we have a professional services team that help our customers build trading applications. Those customers will also have their own developers who are contributing to that same application. And some of the development might even be outsourced as well. So that's 3 organizations contributing to that same application. So basically, we've raised a whole load of questions, and we've said we've got a massive code base. How do we manage that? How do we look after all those assets? We need an architecture to support the complex functionality and these complex interactions. And we need to make sure that all these contributors can contribute to the same code base in a harmonious way without treading on each other's toes. Obviously, the developer needs to be productive. There needs to be the streamlined workflow that they can work through. And all this needs to be complementary. So it's an easy task. So signs of scaling. Hopefully, as I said, some of this stuff will just, you'll kind of go, oh, that makes sense. When you're building a complex application, you end up introducing lots of different dependencies. And each of those dependencies will have their own runtime, their own configuration. But as a developer, you really just want to be focusing on building that piece of functionality. So say you're a Gmail developer and you're building that email composer view. Why do you need the authentication service running? Why do you need the database running? Why do you need a real-time service? You might probably just need the contacts API and the uploading service. But when you get started on a new project, this thing can take hours, to get all these dependencies running on your machine. We found that to be a real problem. Wouldn't it be great if, when you were building this, this piece of functionality, you only needed the service that was related to that functionality you were building, so the contact service in Gmail? It'd be better yet if you didn't need any of these backend dependencies running. You finally get that application running, You get past that loading indicator, and the app's running, but it's just not doing anything. It's unresponsive. Somebody's checked in a piece of code somewhere else that just breaks the functionality in the whole application. It's completely unrelated to the feature that you're building, but this can happen. You know, it can break the app completely, which gets in the way of your productivity. You've got loads of files. Files need to be loaded in certain orders. We've got, you know, these module loaders, but that again, that's something that we came across quite a lot. That files need to be loaded in certain orders. So this idea of concatenation or just, you know, manually organizing script tags, we don't want to be doing that anymore. An obvious one, finding assets is going to be hard. I mean, this is one of our old Caplin Trader 2 based code bases. Where do I find the CSS for a button in a trade ticket here? Where do I find the JavaScript that handles that button click in the trade tile? This stuff, you know, can get difficult, can become a pain. It's JavaScript. We can write JavaScript in many ways to do the same thing. Now that's fine, and it's all very clever that we can do that sort of stuff, but at some point it can become a maintenance problem. We need people to be doing things in consistent ways. So we all look at a piece of code and we all understand how that functions. We can do things with JavaScript that we can't do with many other languages. It's dynamic. I think there's a talk going on elsewhere about why that's brilliant. But also it causes problems. We manipulate the prototypes of standard JavaScript objects. That might be fine in our piece of functionality, but it breaks functionality elsewhere. I found this one really interesting. It's silly, but say I'm building the chat. I'm involved in building this chat functionality down here. So I've edited my code. I go, right, let me see how that reflects in the application. I hit Control F5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 seconds. Every time I make a code change, I'm waiting for 10 seconds before I can see how that's reflected in the application. That, again, is going to eat into my time as a developer. I want to be focusing on building features, not waiting for my app to refresh. And then we've got tests. We're going to have loads and loads of tests. We're building this quality app. We need tests to make sure that we are building this maintainable application. Can I ask who uses Selenium or Selenium? Only a few. You didn't even want to admit it, did you? Yeah, I wouldn't admit it either. No, I mean, it's great and it has its uses, but we found that we were basically doing a lot of testing with the full application. So we had all those dependencies to reset in every single test. We were poking the document object model, and we were finding that our tests were just being unreliable and taking forever. So our continuous integration solution ran on a server farm of VMs and took 8 hours and was unreliable. So during the week, we used to kind of have to measure what our quality gate was. We basically had a percentage, and at the end of the week, we averaged it out and said, is that better than last week? No, that's not how we should be testing stuff. So our solution, taking all these problems, was to create this thing called BladeRunnerJS. So the focus needs to be streamlined developer workflow. We want to be productive as developers. We want to do things in consistent ways so that no matter who comes along, they know how to do something. They look at some existing code, they go, right, I understand how that functions. They want to find an asset, they know where to go. We want to build a single feature in isolation. This is relatively new, it fits quite well with the idea of web components. But we maybe only want the dependencies related to the feature that we're building to be running. Better yet, we don't want those dependencies running at all. We want a way of supporting that, just focusing on building that single feature. And we want this nice term here that just sounds like we know what we're doing. So we want a loosely coupled application architecture. Basically, we want to be able to change the implementation of things without affecting how the application runs. So if we've got multiple components within that, we want to be able to remove one without it breaking how this one functions. This also facilitates testing, that we can change the implementation of something quite easily, maybe with a mock or a dummy, or we can just change how that the thing that interacts with. So we want this nice architecture that fits well with building something that's maintainable. And all this feeds, obviously, into creating a quality product. So let's look at the developer workflow. Again, as I said, it's a focus on features. One of our taglines is focus on features. First line of code is developer code. Again, as developers, we like to be creating stuff. It's best if that thing that we're creating is a feature within our application, provide some business value. So this is the general workflow, which probably fits well with what most people do. The tooling allows us to create an application skeleton. So we're going to create a new project. Let's kick off by creating an application skeleton. We're going to create a new feature. Let's create that feature skeleton. So that gives us basic HTML, CSS, JavaScript, the file structure we need there. If we're doing TDD, we might write our tests first. Or we'll change our HTML, JavaScript, CSS, write and run some tests, and then we'll run this feature in isolation. So again, as developers, we're building a front-end application. We've got some UI components. What does that look like? How does a user interact with it? Let's try it out. Let's do that in isolation. Is the feature complete? If it isn't, we iterate. If it is, then we take that feature and we compose it into our application. We might write some tests at that Selenium style level, maybe manually test the app, build, deploy, and then start on our next feature. So the great thing about building this feature in isolation is that an individual or a team can focus entirely on building that piece of functionality. All the assets for that feature can be located together, the HTML, JavaScript, CSS. We know where we find anything related to that app, the tests, and so on. We don't need these unrelated dependencies running, and we can reduce conflicts with other teams. We're not changing code that other people will be using because we're editing code related to our features. So this is the idea of blades, hence BladeRunnerJS. So let's look at breaking Gmail up into blades. Now, obviously, we didn't build Gmail, but it's this good reference guide. I think the best example is probably the composer view. We can search contacts. We can add a relatively rich content in an email. We can embed images. We can upload and attach things, and obviously send our emails. So it's a nice piece of functionality you can break into a vertical slice of functionality in your app. And then this is an example of another Caplin trader. This is something we call the FX motif. And we're breaking, again, our functionality into blades. We've got grids, we've got charting, we've got news, and we've got our trading tiles. So because we're breaking these things into blades, that lets us do things called workbenches. Now, again, if we look at the older version of Caplin Trader, this is a blade. This trade tile is a blade. And because we've got workbenches, it lets us take that blade and run it within this thing called a workbench. Now, the tooling supports this as a native concept. What we can also do is we can create nice little workbench tools. So this thing here is pretending to be a real-time data service provider, and it's pushing data into this when you click this auto-generate button. This guy over here, this reflects the trade model, basically a state machine, as you execute a trade. And we can click on buttons here and see how this affects the UI. We can obviously interact with this as well directly. So one of the things I find quite interesting about this is that as developers, we've got to focus on tooling at the minute. Node.js is an application runtime, but we're using it to build loads and loads of tools. But the tools tend to be around asset pipeline or developer workflow or concatenation of files or asset pipeline. But one of the great things here is that the tooling that we're building here is to enable us to build features, not to do build stuff. So this is one of the things I'm really excited about our workbenches. So I'm going to do a blade demo. There's no point in me using Caplin Trader in this case as an example. So even Peter this morning mentioned to do MVC. So I'm going to take to do MVC, and I'm going to break it down into what I class as its features. We want to be able to input to-do items. We want to be able to see the to-do items we've got currently. We want to be able to check them, mark them off. We want to be able to delete them and edit them. There's this filter here as well, but I'm not going to do that. Now, this is pre-recorded because I've got 30 minutes, but I did do it yesterday in the hotel room. It might be quite quick. So, as I said, we're around, so if this is a bit too quick, just give us a shout and we'll go through it in person. So we have an SDK, the BladeRunnerJS download. Within the SDK directory, we've got a BRJS executable. We can create an app. Here we're calling BRJS to do. Creating a blade set, that's where we're grouping features. I'm not going to worry about that now. Here I'm going to create an input blade. Then within an apps directory, this is by default, we're looking at improving that. We've got a BRJS to do app folder. I'm going to open up my very trendy new editor, GitHub Atom, and I'm going to go in here, into Blade, input, and you'll see we've got all our assets together. HTML, I18N, source, so JavaScript, the tests, and themes. This is a bit jumpy, isn't it? And here we've got our CSS. So everything related to that piece of functionality located together. In our JavaScript, the first thing you'll notice is we're using this Node.js style require or CommonJS. I think we're doing specifically Node.js. There's something extra we offer that allows for that. We can require the things we're going to use, and we can export functionality as well. So this module exports that. We use knockout by default at the minute. As I said, there isn't any reason we can't use something else. We've got a message property here and a button clicked function. Now, I'm not going to go into knockout.js, but this is just to give you an example of building something. Here's the HTML template. We're going to set the inner text of this to be the value of the message property. And when the button's clicked, we're going to call this button click function. So knockout does that for us. Next, I'm going to kick off our development server that comes with the toolkit. It runs on localhost 7070. Now, part of this, actually, we offer a dashboard that lets you do things like create a new application. You can see your existing apps. Here's the app we just created. I've got my input Blade. I'm going to run it in a workbench. Now, this is not a particularly exciting feature. It's a button and hello world. Over here, you'll see we've got something that knows that we've got this view model idea, and we know we've got a message property with a value of hello world. I'm going to open up the console in a minute, click that button, and show you that the knockout's done its job of calling the correct function on that object. To demonstrate I did it for Fluent, I'm going to change that to Fluent. So this is the next iteration, which is obviously improving this feature massively. So then we've got Hello Fluent. So I'm now saying that's feature complete. It's not particularly exciting. We're going to go into this index.html page. Now we've got this idea of aspects. We don't need to worry about those. It's just your entry point for application. If I go to this BRJS to do subdirectory, you can see it just says successfully loaded the application. Now if I delete this is just to prove we're in the right file. And I go back to the browser and I refresh, we can see that that's changed. So now what I want to do is we've got this class here, brjs_to_do/app. We're creating a new one of those. In source, brjs app.js, we've got this class definition. Now what we want to do here is this is the part where we're composing our application of these different blades, these different features. So I'm going to require this entry point to this blade, the view model. I'm going to create a new instance of it, and then I'm going to use a helper class that we've got in this case called the knockout component. Now all that does is it does the knockout binding, takes the HTML template and binds it to the view model. So I'm going to require that in. And then down here what I'm going to do is create a new instance of that. I'm going to pass in two things. The first one will be the ID of this view, so this string along the top. And the second thing will be the view model. And as I said, internally, that will deal with this binding, this knockout binding. Now in here, the knockout component provides a getElement function, which deals with creating that element for me, and I'm just going to append that to the body. Really simple, but that's the point. Now if we refresh our application, we've got our amazing feature, which is a log me button running in the app. Now obviously, that's not a very amazing example, but you can see that the workflow is really simple. So what I'm going to do here is in the UK we'd call this something like doing a blue Peter, basically something I've done earlier. So I'm going to copy a number of blades across that we've already got because I don't want to go through this already. We've now got an items blade, an input blade, and a filter blade. So I'm going to run my items blade, and you'll see we've got the items functionality now. We've got the ability to check this, the ability to edit. Over here, this isn't actually working quite right. That isn't binding properly. I need to change that. That's my bug. And we can delete things. So we've got this second piece of functionality running. Just to show you that we've got filter input and items, so those new blades exist on the file structure as well. And in here, there's no point in me going through that again. We're basically bringing in these view models. We're creating a component, passing the template ID, passing in the model, getting the element, and appending it here to something called the element with ID to do app. So we've now composed the application of three different blades. So if we launch the app now, we get Blade 1, Blade 2, and obviously some styling's been imported as well. But at this point, these two things don't know about each other. We have this thing about loosely coupled architecture. It's so loosely coupled right now that they know nothing about each other. So the next thing is how do you get these two blades to communicate? So we've achieved three of our goals now. We've got this streamlined developer workflow supported by our tooling. We're doing things in consistent ways. Again, the tooling helps us do that. We've got Node.js style code, so all our code looks in a certain way. And we're composing our features and then adding them to the app. So let's look at application architecture. This is this slightly higher level now. So we need to allow these complex interactions. We need to support developing these features in isolation and doing things like the workbenches. We want to be able to swap components without them having side effects on the rest of the application. And we need to feed this into the app being obviously maintainable. So blades, again, support this. Now, out of interest, who uses Knockout.js in an app? Nobody. Oh, two people, three. Who uses Angular? Okay, a lot more. Okay. So we specifically chose, well, it was actually Knockout 1 we chose, so I don't think there was anything else around at the time. But we actually really like the MVVM solution. So you remember I talked about the 8 hours continuous integration solution. The great thing about MVVM is we've got a view model, which is this logical representation of the view. So if the view contains an input, it might have a disabled property. The view model will have a disabled value on it. And if you change that, it will automatically be reflected in the view by Knockout. So we can test the view model rather than the view and trust Knockout to do the work for us. We still have some tests that test the view, but our focus is around here. We've also got reusable functionality in our domain model that we can use in a different blade and build a different view model in that blade. And then we've got this idea of services. Now I think Angular also has an idea of services. If we think about our to-do app, it might be that there's a to-do service. When our input blade goes, someone wants to create a new to-do item, we might get the to-do service and go, add this new to-do item. In the items blade, it might go, right, get me a list of existing to-do items, or update to-do items, and also tell me when anybody adds new to-do items. So these blades aren't directly communicating with each other. They're doing this through this intermediary service. So services fit really well for the idea of persistence, for accessing backend resources, RESTful services, for real-time services. So in our Caplin Trader applications, we've got real-time grids and we've got real-time trade tiles. Both those things access a real-time service. And we do this through something called a service registry. So the benefits of this are, as I said, that blades don't communicate directly. They're indirectly communicating through this service. Functionality is encapsulated behind an interface. Now, I don't know what, as JavaScript developers, we think of interfaces. Sometimes you have big arguments about that, and we've had that internally. But we just think about them as contracts. You get something from this service registry, and you know it has certain functions that take certain parameters and has certain return values. It's just a contract. And by default, because you're interacting with just a contract, not an implementation, you've got this loose coupling. And the great thing about that is that in our different scenarios, in our workbench, in our tests, in our app, we can provide different services. So we can have a service that is actually a workbench tool, but is pretending to provide real-time data. That's in our workbench scenario. In tests, then obviously, we can inject mocks and dummies and facilitate our testing. And when we're running the application, we inject the real things. So let's have a look at the services demo. In this demo, we're going to use just an event hub, a really simple way of loosely coupled communication. So at this point, we've got our two blades, the input and the list. There's actually a bug where the filter one's not showing. So let's have a look at the items view model to see how it's communicating with the event hub. So it's grabbing the service registry using require. This is a default thing that exists in BRJS apps, as is the event hub. We get it through this logical name, BR event hub. Over here, we're referencing a channel called to-do list. We're saying when the to-do added event is fired on that channel, call this to-do added function. And then in our to-do added function, we grab the content, we create a new view model to represent that added item, and we push it onto a to-dos array. Now again, Knockout handles the binding and the auto-updating of the view there. So in our input view model, we want to grab hold of that service registry, we want to get hold of that event hub. And then down here, when the enter key's been pressed, we want to trigger information over this event hub. And we want to be saying, it's on the channel to-do list. So this is the only real contract between these two things. It's the only things that they really know about. They know the name of the channel. They know the name of the event that they need to trigger if something's being added. And they need to know the payload. So the payload here is, it just has a title property and it passed the contents of the text, the to-do item text. So that's that blade now functioning. So the workflow is, let's go into that workbench. Let's see that running. I can enter some content here. You'll see this will also automatically update. And over here, we've got this little event hub logging tool. And it's saying, somebody subscribed to the to-do list. Somebody triggered an event on to-do added, and this was the payload. So these little tools help that workflow. We know that blade is functioning. We'll obviously write tests around that too. So now if we go to our app, we'll be able to do that. We know that blade will then fire an event over the event hub. And this blade down here will be listening, and it can add that item to the list. Really, really simple. So we've now achieved this fourth goal, this scalable, loosely coupled application architecture that will facilitate testing. We've got MVVM that's got loose coupling between the view and the view model. and also at the domain model level. And we've got this idea of interfaces or contracts. That means we're not interacting with an implementation, just this contract. So quality, all this is fed into us having this quality application. As a developer, we're productive, we're happier. We've got these standard ways of doing things. We're following conventions. We're doing things in consistent ways. We've got ideas of blades and workbenches. We know where to find our assets. We have a set coding style and structure and architecture. We're consistently using the same architecture, so that's another benefit. Everything facilitates testing, this loose coupling, and we can easily swap out implementations. And we're avoiding hitting the DOM, which, as I said, was one of our big pain points. So I'm not going to go into this because I'm massively running out of time. So we have JS test driver support within our toolkit. We chose that a number of years ago. We've got this test plugin now that wraps that, so we're looking at things like Karma. And also Node.js integration. Although our toolkit's Java, we know that Node has a big community and we want to get involved in that, but we can't just go, we're going to use Node because some of our customers won't allow Node even in their development environments. So here's the biggest win. We've now got our view model and we've got services. So we can write tests, poke the view model, and have mock services and see what the interaction was within our completed feature. We can do things with our pretend service and see how that affects the view model. So we're running tests at this full feature level now. And we've got a nice testing triangle, and this represents these blade functional testing, this end-to-end piece of functional testing, using this view model through to interfaces. And we actually do those in a given when-then style and create some specs, some testing fixtures to help us with that. And the proof really is here that it used to take us around 8 hours or more this isn't our server farm, but something like that. And now on my machine, it will take less than 30 minutes with more coverage. But also, because we're building our single features in isolation, we can actually run our tests against our single piece of functionality in much less time, and we know it won't impact the other functionality in our app. So we've achieved all these goals. That's brilliant. So in summary, we've got this toolkit. We've got the streamlined developer workflow. The focus is on features. They know that first line of code. You've seen from the demo, the really quick demo there, straight away we're writing code, we're writing functionality. We've got blades. We've got all our assets grouped together. Got a set way of doing things. We've got services which enable testing, enable things like the workbench tools and the workbenches. And quality is really high. We've got testing at the class level and also this feature level. So we're at Fluent, myself and Patrick sitting here. We just open sourced. It would be great to get feedback, speak to people, find out what you think, feed into things you didn't like so that we can potentially change them. Part of this open sourcing project is to learn and to think of how we can improve our own development workflow. So that's one of the reasons we've open sourced this. We've got this Birds of a Feather session tomorrow, table 7. So that's it. Thank you very much for your time. That's it. Great. Thank you.